Okay, so for the first one here, sine of 60, that's pretty straightforward. You're just going to punch it in your calculator, sine 60, and what do we get? 0.866, good. Cosine of 60, we're going to just type in cosine 60 and we're going to get 0.5. Tangent of 60, same thing, just hit tangent and type in 60. 1.732. Secant of 60. This is a little trickier. What trig function and which one of our three big ones is secant related to? Cosine. So you remember you do the cosine of 60 degrees, hit equals, and then you do that x negative 1 key. And that tells us that it's going to be 2. Very good. Secant, or cosecant, is related to the sine. That's one that always confused me. It took me a while to keep that straight. Secant goes with cosine, and cosecant goes with sine. It seems backwards, but that's just the way it works out. So you have to go hit the sine of 60, and then hit that x negative 1 key, and it comes out to be 1.154, 1.15. There we go. And then cotangent of 60. Again, that's related to tangent. So you do tangent of 60, hit equals, and then hit that reciprocal key to get 0.577. Good. So there are some relationships here that we've already established, and that is with these bottom three functions. Since those buttons do not occur on your calculator, you have to use the related function, the reciprocal function. So the secant is the reciprocal of the cosine. And the other way around, cosine is the reciprocal of the secant. So if we know either one, we can find the other one really quickly. And the cosecant is the reciprocal of the sine. And again, the other way around, the sine is the reciprocal of the cosecant. So if we know one, we can find the other real quickly. And of course, the cotangent is the reciprocal of the tangent. And of course, the other way around. There are a lot of these. These are what we call identities. And all an identity is it's expressing one trig function in terms of one or more other trig functions. And there are several of these that we are going to run into as we go through things. For example, the sine of an angle based on the sides of the triangle. Do you remember what sides the sine deals with? Opposite over hypotenuse. Very good. And the cosine of an angle is adjacent over hypotenuse. And finally, the tangent of an angle is opposite over adjacent. So one of the things we can deal with is let's just take the sine divided by the cosine. Well, the sine is opposite over hypotenuse. The cosine is adjacent over hypotenuse. So if we divide these two ratios, opposite over hypotenuse divided by adjacent over hypotenuse. Remember, when we divide fractions, we take the reciprocal of the one we're dividing by and we multiply. So this is going to become, the opposite over hypotenuse doesn't change. This is going to become hypotenuse over adjacent, and you see that the hypotenuse cancels out. That's just opposite over adjacent. Well, that should look familiar. That's our tangent. So one of the relationships we have, similar to these identities here, a fourth identity that we have is that the tangent of an angle can be found by just dividing the sine of that angle by the cosine of that angle. And there are going to be several of these identities, other types of identities like this that we're going to run into as we go through this stuff. For today, we want to talk about the opposite of what we did yesterday. I mean, yesterday, these first several... Did you go to need there, Gash? Yesterday, we talked about if you're given the angle, finding the value of that function. You know, we looked at if you have the cosine of 40 degrees, how do you find it? And we used the calculator, this cosine of 40. You know, we mentioned if you don't have the calculator, so 0.7660. We had mentioned if you don't have the calculator, the only other way is to use trig tables, which is quite messy to do. There are standard trig functions, and we talked about that circle, and how all these functions come off of that circle. And there are standard trig functions that have standard values. For example, the 30 degrees. You've seen me use 30 degrees and 60 degrees quite a bit. Well, 30 degrees have pretty set values, and 60 degrees is the complement of that.
What are we doing now?
I'm just kind of giving you some background information. What we're going to be doing is we're going to go the opposite direction. It's called inverse trig functions. So if this is 30 degrees, the values of sine, cosine, and then our tangent out there are pretty standard. And those are ones that I was forced to memorize when I took a trig class. I'm not going to force you guys to memorize them because you're always going to have your calculators to do this for you. It's not something I'd ever expect you to do without a calculator. But there are some that we'll run into that you will get familiar with, and they pop up often enough that you will start to know them off the top of your head. So anyway, given the angle, finding the value of the trig function is just on your calculator. When we did the secant of 40 degrees, we had to do the cosine of 40 degrees, hit equals, and then do that x negative 1. So this is the cosine. If I do the x negative 1, it'll give me the secant, 1.305. So some things we should know about these trig functions. Since the radius of this circle is 1, because it's the unit circle, the value of the sine, the largest the sine could get would be if the angle were right here, and this is the sine. Well, what is that value? The radius, 1. So the largest the sine can be is 1. So the sine of an angle is always less than or equal to 1. Well, the largest the cosine can be is right here if that angle were at 0, and that's also the radius. So the cosine also is always less than or equal to 1. And to be more specific, if the cosine were over here, technically that would be considered negative 1 because of the way the graph is set up. So the cosine is always between negative 1 and positive 1. And the sine as well. If it were down here, that would be a negative 1. So the values of the sines and cosines, because they're on this unit circle, are always between negative 1 and positive 1. The secant always has to cut through the circle and go out of the circle. Because of that, the secant is always at least the radius. So the secant of an angle is always greater than or equal to 1, or less than or equal to negative 1, because the secant can be negative. Cosecant is going to be the same way then, because it relates to the sine, greater than or equal to 1, or less than or equal to negative 1. Tangent and cotangent can take on any value because they're that ratio between the sines and cosines. We'll look at those more in the next several days. The cosecant is just the reciprocal, or the cotangent is just reciprocal of the tangent. So it just flips that over. But these are the big limits you have to worry about. And the reason I'm pointing those out is in our next step here, we're going to look at if I'm given the sine of an angle, I'm just going to say sine of A is 0.732, how do I find angle A? Well, I believe it was Spencer that asked yesterday about you have that sine -1 key, the second function above your sine, and is that doing this? And it's not. That's what's called an inverse sine. All of the functions we have done in this class come in pairs, and they're called inverses, like adding and subtracting. If you add 3 to a number and then subtract 3, you get back to where you started. Multiplication and division are the same way. You multiply a number by 7, then divide by 7, you get back to where you started. Powers and roots are the same way. There are all sorts of other ones. You get logarithms and exponentials, and all those have the same thing. Trig functions are set up the same way. If you take the sine of something, to reverse it, you would do the inverse sine. So right here, to solve this equation, we're taking the sine of a. To get a by itself, we would do the inverse sine, and that would cancel out the sine. So that notation, sine with that little -1 up there, is one of the ways of expressing an inverse sine. So that cancels out. So here we have a equals, now how do we do the inverse sine of 0.732? Well, on our calculator, it's just like taking the sine, only we have to hit second first. And then you can see above your sine key, it says sine -1. That's your inverse sine function, 0.732. Gives us 47.05 degrees. So that sine with a little -1 is one of the notations you will see for inverse sine. So as we just saw, the inverse sine, 0.732, is 47.05 degrees. Other notations you will see for inverse sine. You might see it written as INV-SIN, inverse sine. The other one is a very old notation that you don't see much anymore, but you're going to run into it. I know it's still in the machinery handbook in a couple of spots. Arc sine. The ARC sine is also another notation for writing inverse sine. So these three notations here mean exactly the same thing. What they are saying is what angle has a sine of 0.732. So the result for all of those would be the 47.05. So if I tell you that the cosine of angle B equals 0.415, how do I find angle B? Well, B is going to equal the inverse cosine of 0.415. So again, it's second cosine, 0.415. 65.48 degrees. I'll give you guys a second to do that to work on your calculator. So on your calculator, you got to use the second or shift key, and then press the cosine key, and then 0.415. Nope, you got to hit the second key or the shift key, so up in the top left. Then you hit the cosine, and then put in the 0.415. Did you get 65.48? Okay. So what if I tell you that the sine of angle C is 1.38? Find angle C. So did I give you an error? Yep. Why? Yeah. That's why we pointed this out up here. The sine has to be between -1 and +1. That is greater than 1, so that's not possible. The sine can never pass outside of the unit circle. It can never be bigger than the radius.
tricky, huh?
Well, that comes in there when we're doing some of our stuff. In a few weeks, we start doing law of sines and law of cosines. We're going to run into where you're given information for a triangle, and it doesn't actually form a triangle. So you'll run into that. Oh, the value of the sine is greater than 1, so you know you can stop right there. This really doesn't form a triangle. Okay, how about the tangent of angle D is 7.84. Now, is that possible? Yes, it is. The tangent can be any value. So second tangent, 7.84. Oops, didn't get my second in there.
Tangent and cotangent can be any value, right?
Yes, tangent and cotangent can both be any value. So what'd you get for the inverse tangent of 7.84? 82.73 degrees. Perfect. So sine, cosine, tangent are relatively easy to find. How about if I give you the secant of angle A is 2.4. Now remember, let's go back and review. If I asked you to find the secant of 70 degrees, how did we find that? Well, we did the cosine of 70 degrees, hit equals, and then we did that reciprocal key, right? Cosine 70 equals x negative 1. So you got 2.924, whatever, for that secant. Up here, we have to reverse that process. The last thing we did here was to do the reciprocal. The first thing we do up here is the reciprocal. So we're going to take that 2.4, hit that x negative 1 key, and then equals. So 2.4 reciprocal equals. Next, we're going to undo the cosine part of it. So we're going to do an inverse cosine. So we're going to do second cosine, inverse cosine, then second answer. So that previous answer. So 65.38 degrees we're getting. Everybody get that to work out? So you're going to type in the 2.4 first. So type that in. Then you hit the x negative 1 key. Then hit equals. Then you're going to do second or shift cosine. And then you're going to do shift and then answer, the answer key. So it puts that previous answer back in. So you're taking the inverse cosine of that, the answer of that. Now there is a way to enter this in smoother so you don't have to use that answer key.
Where's the answer key?
Which you should be right on your negative key if you hit second, and then it's down right by your equal sign, just left your equal sign. It should say ANS.
You have to hit second ANS?
Yep. Now there's a way you can enter this in all in one line. It's just a little bit confusing because it is reversing this order, but it's using order of operation, so it doesn't look like it's reversed. And the way you could enter it in is just like this. So the secant, or the inverse secant of 2.4, you can enter it in your calculator as the inverse cosine, so the second cosine. Then in your parentheses, you put in 2.4, then hit that x negative 1 and close your parentheses. So you're going to do it like this. Second cosine, to put in the inverse cosine, 2.4, and then before I close my parentheses, I hit that inverse, that x negative 1 key. Then I have to make sure I close my parentheses. And this should give me the same thing. And there it is, 65.38. So those keystrokes again, second cosine or shift cosine, 2.4, and then the inverse, the reciprocal key. So shift cosine, and type in the 2.4, hit your x negative 1 key, close your parentheses, and hit equals. There you go. Okay. So now based on that, let's see if you guys can figure out, if I give you that the cosecant of angle B is 1.85. Find angle B. So what trig function does cosecant go with again? Sine. So what we're going to do is this. We're going to do the inverse sine. So that's the second sine or shift sine. Then put in the 1.85. Then we're going to do that reciprocal key and close our parentheses. So second sine. Oops, sorry, clear it out. Second sine, 1.85. Reciprocal, close our parentheses. 32.72, did you get? 32.72 degrees. So you're going to hit shift sine again. 1.85 sine. 1.85. Then the x negative 1. Close your parentheses. And then hit equals. Either that, or if you try to hit equals in the middle of that before you hit the x negative 1, it's going to give you an error. You can't hit equals to the very end of that one. So if I tell you that the cotangent of angle C is 0.375, finding that inverse cotangent, what function are we going to use? Tangent, yes. So the inverse tangent, 0.375, but what do we have to do before we close our parentheses there? At the reciprocal key, the x negative 1. So again, second tangent, 0.375, reciprocal, and close our parentheses. 69.44. So now with this ability to do inverse, we can actually solve equations with these in them. So we might have 3 times the sine of angle A plus 1 equals 2.8. If I want to solve that equation, it's just like solving an equation for x. There's just an extra step at the end. So I'm going to treat this like my x, like my variable. And I have to get it by itself. So what do I have to get rid of? The 1 and the 3, and the 1's going to be the first thing we get rid of. So we'll subtract 1. So here we still have 3 times the sine of A. 2.8 minus 1 is 1.8. What's our next step? Divide by 3. So sine of A, 1.8 divided by 3 is 0.6. And now that we have that trig function isolated, we do the inverse. There you go. The inverse sign gets rid of that. So A here is just the inverse sine of 6. So second sine, or inverse sine of 0.6, I should say. So second sine 0.6 is 36.87 degrees. What's that? Yeah. So we had this equation here, and we're treating this here like that's the x. So we're going to solve it like any other equation with the x there. We subtracted 1 to get 1.8. Over here, the 1's gone, so all we have is the 3 times sine of a. So you divide it by 3 to get rid of the 3. 1.8 divided by 3 is 0.6. So now that we know that the sine equals 0.6, to solve for that angle, solve for a, was just an inverse sine. So you just type in on your calculator, shift, for you it's shift, sine, and then 0.6, and close your parentheses, and it equals.
Wait, so what can we then put the next negative 1 in there?
It is, it's the shift sign. This is because it's just a sine. It's not a secant or cosecant or cotangent. It's just a straight function. Yeah. That x negative 1 is only for sine, cosine, or for secant, cosecant, or cotangent. So what if we have 5 times the cosine of b minus 3 equals 1.5. Find b for me. I'll give you a minute to see if you can come up with that. So to solve this, we're going to add 3. So 5 times the cosine of b, 1.5 plus 3 is 4.5. Then we're going to divide by 5. So the cosine of b equals 4.5 divided by 5 is 0.9. And now that we've got that cosine isolated, it's going to be an inverse cosine. So second cosine of 0.9, 25.84 degrees. Let's try a tough one. Three times the secant of angle D plus 2 equals 5.6. So talk me through it. We'll do this one together. What do I do first? So we will subtract 2. Good. So 3 times the secant of D equals 3.6. What's next? Divide by 3. So the secant of D, 3.6 divided by 3 is 1.2. And now we just have to do inverse secant. Well, since secant isn't one of the buttons on our calculator, that's where we've got to use one of the other functions. So secant means we're going to use cosine. So we do the inverse cosine, 1.2, and then this time we do have to use the x negative 1 key. So second cosine, 1.2, x negative 1, 33.56 degrees. Any questions?
Now, I realize that this is what you have to do to get this answer, but why do you second cosine? That's the secant already.
Nope, second cosine is the cosine. To make it a inverse secant, that's what you got to put this x negative 1 here. putting that x negative 1 after the number is to convert the inverse secant so it can be done with an inverse cosine. So the combination of the inverse cosine here and the x negative 1 in here, that turns it into an inverse secant. That's a great question, though, of why do we have to use both of them together? Let's say I tell you that sine of angle A, well, equals 0.783. And I tell you that A plus B equals 90 degrees. There are some things that I know from this. For example, what's the cosine of angle B? It's a different way of wording it, but A plus B equals 90 degrees is telling me that A and B are complementary. They're complements. And if those are complements, the sine of one equals the cosine of the other. If A and B add up to 90 degrees, if they're complements, the sine of A has to equal the cosine of B. If I tell you the secant of C equals 2.875, and I tell you that C plus D equals 90 degrees, what's the cosecant of D have to equal? 2.875, yes. Again, if C and D are complements, cosecant is saying what is the secant of the complement. So the cosecant of D is asking what is the secant of C. So again, if those two angles are complements, the secant of one will equal the cosecant of the other. If I tell you that the tangent of angle F equals 7.2, and if I tell you that F plus G equals 90 degrees, I'm going to do this a little backwards on you here. What function of G is going to equal 7.2? Cotangent. Very good. And that does work backwards too. If I tell you that the cosine of angle H equals 0.814, and I tell you that H and J add up to 90 degrees, the sine of angle J has to be 0.814. Okay. That's one that I do mean to pound. I was about to say I don't mean to pound it in your head, but I do mean to pound that one in your head, because you see that it saves you a lot of time to not have to punch that in the calculator when you see those. Just be able to say, okay, they're complements, so the sine of one has to equal the cosine of the other, or the tangent of one has to equal the cotangent of the other.
That's only when they're complements?
Only when they're complements, yes. Now there are going to be other identities we come up with that are going to be a little bit more complex than those. Like we already saw, the secant is just 1 over. But if I tell you that the cosine of an angle of A is 0.8, what's the secant of A? Well, it's the reciprocal of 0.8. So 1.25. On the calculator, you can just do 0.8 x negative 1 for reciprocal. Or you could do 1 divided by 0.8, either way.
do the secant.
Yeah, I think you've got there. If you knew the secant, the cosine is just one. If I tell you the secant of an angle, if I tell you the secant of angle B equals 4, then you know the cosine of B equals 1 over 4, or 0.25. Okay, I'm going to have you guys practice out of that packet we gave you yesterday. Page 341 to 342. It is 75 through 121, the odds. It's going to be finding inverse functions. So it's going to tell you the sine of angle A equals whatever. You have to do the inverse. I'll let you guys have the last 11 minutes to get started on those.